Hey everybody, what's up? Mr. Smith checking in with y'all. I know things have been crazy, but we got to keep moving on. We got to keep grinding. So just to kind of touch base on where we've been and where we're gonna go. Tuesday, October 8th was a independent learning day. I did have office hours 9 a.m. to 10:30 and also 1 to 2 p.m. Um, my boy Tyler Winston came and saw me, and we worked through the strings practice together, and he got it turned in. So, guys, please join these office hours. Definitely join so you can come get some help. Uh, so that and the Mad Libs, guys. Friday. I'm putting those grades in. If you didn't do them, they're going in as a 0. I know we're at home, but you there's a certain expectations, right? So looking at it, I'm making this video right now. This video is going to be about wrapper classes in the math class, and I'm going to get this uploaded for you this morning so you have it today to help you work on this stuff. Next week, we've got to have our summative, guys. I know we're synchronous learning, but Tuesday is going to be synchronous. I do have a Teams link here for you to join me. And we will be all in teams together like it's a normal class. We're going to go through some review to get you ready for your test. Thursday and Friday, I'm out. I'm actually flying to Texas to see my best friend. So I am going to open up your Unit 2 test. It's multiple choice and a free response. As long as you go through, and you do look through the review sheet, you do the review practice, you show up to class. We're going to go through all that. You do, maybe go through the Jeopardy game to test your knowledge. You'll be fine on this, all right? And I'm giving you all day Thursday and Friday to get it done. It'll close on Sunday. But yeah, I mean that's next week. But so for today, all right, this is Thursday, October 10th, Independent Learning Day. I do have office hours from 10 to 12:30. That is because we have a faculty meeting at 1. So I changed up the office hours a little bit today. So the wrapper classes, all right, we're going to talk about those and also the math class, and then I have this practice for you. So I am going to first start by talking about wrapper classes. So I am going to turn off my camera so that way you can get my full screen here. All right, and from beginning. So, wrapper classes, guys, basically they are this idea that, hold on, I gotta double check. Okay, yeah. It's this idea that when you're using objects, you can create objects of the primitive types, basically. So, primitive types to review back in the day, very first couple weeks of school, we had int, we had double, we had float, we had all those. Those were our primitive types. So what a wrapper class is, and what it allows you to do, is it allows you to reference a data type, or a primitive data type using objects. All right, so uh, basically it's gonna be an object version, and the way that you recognize this is through capitalization. So for instance, ints was lowercase int. The wrapper class version of that is integer with a capital I. Double was lowercase d, O-U-B-L-E. The wrapper class version is going to be a capital D, O-U-B-L-E. All right? Because it is an object. We indicate those with a capital letter at the beginning of the word. All right, these are found in the java.lang package, so you don't have to import anything. They're inherently imported when you are just using Java, so you can call them at any time. All right, so the following integer methods and constructors. All right, so because we're so used to the int primitive type, but now we're using the integer wrapper. All right, wrapper object. It has its own methods and constructors that you can use. All right. So for instance, if I call integer and pass a value into it, so I'm actually going to go off full screen. All right, integer, and I pass a value. What it is actually doing is creating an integer object. All right, so integer my num equals new integer. All right, integer min value, what it is actually doing is it is getting the minimum value represented by an int or an integer. All right, so I will actually demonstrate that. Same thing with max value. Max is the max value. And then we have int value. All right, so int value returns the value of this integer as an int. So if you have an object and you call int value, it gives it to you as an int. All right, we also have a double. Double, this is the constructor call. So the wrapper double passing a value actually creates a double object. And then here, double value returns the double as a value. All right. So let's try it out, right? We're so used to seeing int, but now that we're into objects, you know that you can use integer. So I can create an integer object called mynum, and I'm passing in the value 5, which means 5 is going to be stored into mynum. This basically means that it is the same thing as saying int mynum equals 5. But we're using objects, so that way we can also have access to the methods of the object. All right, double dubs equals new double 4.5 is the same thing as saying double dubs 4.5. All right, one is just the primitive way of doing it, and the other one is using a wrapper class to make an object. All right, autoboxing is the automatic conversion that a Java compiler makes between primitive types and their corresponding object wrapper classes. All right, so this means that, like this term autoboxing, means you're converting an int to an integer or a double to a double. All right, so int is the primitive type, integer is the object type or the wrapper. All right, the Java compiler applies autoboxing when a primitive value is passed as a parameter to a method that expects an object. All right, so if you have written a method that wants an object and you pass in just a regular old primitive int, it'll do autoboxing. Or it's assigned to a variable of a wrapper class. So if you assign an int to an actual object. So here, integer a, integer, right? This is the wrapper. It's an object, capital I, full word, integer. Integer a is equal to 10. Well, this 10 is just a regular old int, so autoboxing is applied there. All right, system.out.println a.compare to -7 prints off a positive number since 10 is larger than -7. All right. Unboxing is the conversion that makes the wrapper class primitive. So going the other way, you're going from the object back to the primitive. So integer to int, double to double. The compiler applies unboxing when in the following cases. So it's passed as a parameter to a method that expects a value of a primitive type, so just the opposite, or if it's assigned. All right, so pretty straightforward here. Integer capital I equals new integer 18. But then if we have an int and we assign it to object, which is this here, this object is an actual integer object 18, but we're assigning it as an int, it's called unboxing. All right, if we think back to our dog class from lesson 1, integer age equals new integer 7. All right, but then here, when we create a dog, it's expecting an int primitive type, and we're passing in an int object, so that would be unboxing. All right, so that's basically it for wrapper classes. We're going to practice it at the end of this video, but just kind of wanted to run through that. So now we're going to move on to the math class. All right, math class is pretty straightforward. So the math class is part of the lang package, all right, with java.lang, which is the same thing the wrapper class was part of. It also gets automatically imported, so you do not have to import the math class. The math class contains static methods, which means that instead of using an object to call the method, we use the class name before the dot notation. All right, so instead of having an object, so let me show you. Normally we would have like object name and dot method name, but because math contains these static methods, we can just say math dot. So you don't have to have an object to use the math class methods. We are going to talk about static methods more later. You can use a ton of math methods, but there's only 5 of them on the AP exam, so those are going to be the focus today. All right, so those 5 are ABS, all right, which stands for absolute value, all right? So if I have int absolute int x, it's going to give me the absolute value of that integer. All right, so what is the absolute value of -7? It is 7. You just make it positive. Same thing, absolute value, but for a double. Absolute value, but for a double, it returns the double absolute value. So 5.67 is 5.67. All right, so it returns the positive version. POW stands for power, which is raising something, doing exponents. So when you have an exponent, you have a base and you have something it's raised to. For instance, you have like 6 raised to 25th, right? This is your base, and this is your exponent here. All right, so instead of it being called, whatever, it's called POW, P-O-W, and we have a base and we have an exponent. All right, so it's just going to return that value. So if we have 4.5 and 2, it'll be 4.5 squared. I don't know that off head, but 16 point something something, maybe. I think so. Oh, no, I was 20. I was close. 20.25, all right? Double SQRT is square root, so you put a value in there, and it returns the positive square root of a double. So square root of 25 is 5. Notice it's double because it's double. And then we also have random. It's going to give you a random number between 0.0 and 1.0. So like it'll literally just give you a random number, a random decimal number. And I will teach you how to manipulate that to get a random whole number you want. All right, so let's look at some examples here. We have x equals 9, y is equal to 2. So our answer, 1, is the absolute value of y minus x. So 2 minus 9, I'm going to let y'all process. 2 minus 9 is -7. But then we're doing the absolute value of -7. So that would be, oh, there we go. 2 minus 9, absolute value would be 7. All right, looking at this second one, 9 and 2, we're going to do POW, so the power, so an exponent. It looks like our base is 9 and our exponent is 2. So 9 raised to the second power is 81. All right. X is 9, y is 2. Now we're going to do the square root. All right, but we're doing the square root of x. So math dot the square root of 9. So what is the square root of 9? I do believe it is 3. So 3 times 2 is 6. Beautiful. Notice it's 6.0 because math.square root returned a double, and we stored it as a double. All right, random numbers. This is what I was talking about. So math.random gives you a random decimal number between 0 and 1. So a random decimal number between 0 and 1. We can actually manipulate that. So like, for instance, it could be 0.9666 or whatever. It's going to be random, all right? But we can manipulate it to give it a like whole number. So for instance, if I take double decimal and I say math.random times 10, it's going to move it over. So the smallest version of this is 0 times 10, which will give us 0. And the largest number of this is 0.99999 times 10, which will actually give us 10. All right. So if we multiply math.random by 10, we can get numbers between 0 and 10. So inherently, if we multiply it by 100, we can get decimal numbers between 0 and 100. If we cast it to an int, it'll give us 0 to 9, right? So it doesn't actually make it up to 10. It goes from 0 to 0.999999, and then we multiply them by 10, so that's 0 to 9.999999. So if we cast it as an int, we just drop the decimal, so that gives us 0 to 9. All right. Then same thing, 0 to 99. But if we wanted 0, let's say we wanted 1 to 100, if we add a plus 1 on the end, now it takes that 0 to 99, and then we add 1, and it makes it 1 to 10. If we add 8, it goes from 8 to 107. All right. So you just got to kind of learn how to manipulate math.random to get your random number range that you want. All right, so the way you manipulate it is actually this algorithm here. Int rand number is equal to int math.random times your range plus the starting value. All right, so if you want 100 numbers, range would be 100. If you wanted it to start at 60, your starting value would be 60. So it would go from 60 and give you 100 numbers. All right. All right. Write the code to generate a random number between 15 and 35. So I'm going to go here and just kind of use this to show you. So if I wanted a random number between 15 and 35, pull that over. Pull it over some more. All right, random number between 15 and 35. So what is our range there? Well, our starting value is going to be 15, right? And then I believe the range on that is 20, right? Isn't that 20? 20 numbers? Could be a little wrong. So that's how you've got to think about it. So if we actually look, so the range was actually 21 values. All right, because I guess you got to include 35 at the end. So starting value is 15. There we go. Okay. Starting value is 15. So we do int rand number int math.random times 21 because you got to include that 35 that I forgot about plus 15. So write the code that simulates rolling 2 dice and calculating the sum. We'll get into that more when we're into class, but basically if you wanted to roll a dice, it'd be math.random times 6 plus 1, then you would add them together, okay? So that's it, guys. That's math. That's the math class. So it's just 5 things you've got to know. You've got to know integer absolute value. Let me get back up to the top. Where are you at? Yeah, you got to know integer absolute value, double absolute value. You've got to know exponent, so the power, POW. You need to know square root and math.random. All right. So let's actually put this into practice. All right. So what I want you to do, your assignment for Friday, October 10th, today, is I want you to go through and work these out. So like for this, I'm going to do a few of them with you. So for this first one, it should be very easy. The absolute value of 5 is 5, right? Big easy right there. Nice, easy one. Absolute value of 4.5 is 4.5. All right, again, pretty easy. Then you're going to do power. So 4 raised to the third. 4 times 4 is 16. 16 times 4 is 64.0. Okay. Make sure if it's a double, you make it a double. All right. I might start taking off with that pretty soon. All right. So I'm going to let y'all finish those. Y'all can figure those out. All right. Here's the math.random, right? So in the math.random, we went over this one. So the range is 10 numbers, right? So it normally goes from 0 to 1, but because we multiply by 10 and we make it an int, this is our 0 to 9. All right. So if we multiply by 11, all that is going to do is add one more number to our range, so that is 0 to 10. If we multiply by 100, it's going to add more to our range, so it's going to go from 0 to 99. Here we multiply by 10, so we know that this is really 0 to 9, but then we're adding 2. So 0 plus 2 is 2, and 9 plus 2 is 11. All right, I hope you're starting to see how that works. Y'all can finish that. Okay, consider the following code. Double x equals negative 37.6. So, let's plug it in. Minus 37.6. So the absolute value of negative 37.6 is 37.6. And then we int it. So that means we drop the decimal. So 37.6, drop your decimal. And it's going to be one of those. I think you guys got the hang of this. I don't want to give away too much. So I'm going to let you finish that. Mr. Smith, your teacher, I will be in office hours today, October 10th, from 10 a.m. to 12:30. Please come join me. We can work through the rest of those problems if you need help. Otherwise, you're on your own. Again, next week, Tuesday, will be synchronous. I will meet y'all in this Teams link here. So click on this at our normal class time, 11:30. 11:30 on Tuesday, you'll click that. We're going to do some review before you take your test next week while I am gone. All right? So that's it for me, guys. Please come see me in office hours. Y'all be good. Y'all stay safe. Peace.